Okay, so G part 2 says hence state the value of limit n tends to infinity of PCn for integers greater than 2. So that should be the same as G part 1 answer that we found here. So it is going to be that's also be 2 pi. That's just one mark question. So that's G part 2 and this is G part 1. Okay, so now part H says use the result from part D and part F to determine an inequality for the value of pi in terms of n. So for this we have to go to the result of D part, which was this. It says limit n tends to infinity 2n sine pi by n is 2 pi. So we see that if we just look at the diagram, the n-sided polygon or the hexagon, we see that the perimeter of the n-sided polygon is approaching the circumference of the circle, but it's always less than is approaches means is less than the perimeter of circle. So what can we do? We can write this as the inequality as, so this was reaching 2 pi. So 2 pi is always greater than the result n sine pi over n. This was the result in part D. Let's just recheck quickly. It's 2n in fact. So it's 2n and this. Now if we look at the second diagram where the polygon is circumscribed the circle, so we know that it's always greater than the 2 pi r is 1, and the result was 2n 10 pi by n. So the circumference 2 pi r should be less than this 2n 10 pi by n value. So we can write this as 2n 10 pi over n, and we can simplify it to n sine pi over n. Since we have 2 common throughout, so we can cancel out 2. So we can write n sine pi over n less than pi, and is less than n 10 pi over n. So this is the inequality required in this part. So in part H they said use the result from part D and F to determine the inequality for the value of pi in terms of n. Okay, now the last part is they said the inequality found in part H can be used to determine the lower and the upper bound of the approximations for the value of pi. So in this part they are saying that determine the least value of n such that the lower bound and the upper bound approximations are both within 0.005 of pi. So what does it mean within 0.005 of pi? If we look at the upper bound, it is this value is this part of the inequality n 10 pi over n, and if we take the difference from the pi, this value is approximating the pi value, so it's almost pi, but there is an error. So they said it should be within 0.005, so it should be less than 0.005. You can bring 0.005 to one side, so you can write this as 10 pi over n minus pi minus 0.005 less than 0, or you can also write this as, if you take these terms left side terms to the right side, you can write this as 0.005 plus pi minus n times of 10 pi over n greater than 0. Now you can use your GDC to solve the equation, like solution of the equation. If there was a equal sign rather than the greater than sign, you can use the GDC to find this solution. So use GDC. So if you use GDC, the equation solver whether you have the TI-84 or Casio calculator, you can solve the equation in that. So if you use GDC, you will find that n should be greater than 45.2. So that makes it n equals to 46 onwards. Since n is an integer, so it should be greater than equals to 46. So from this inequality, the least value is 46. Now if you look at the other side of the inequality, it says n sin pi by n less than pi. So we'll take the difference there. Now since the n sin pi by n is less than pi, now we know that, so we subtract it from pi. So it's pi minus n sin pi over n should be less than 0.005. This is the condition they have given in the question. Let's just go back to the question and check. It says determine the least value of n such that the lower bound and the upper bound approximations are both within 0.005 of pi. So it means there is an error of 0.005, maximum error of 0.005. So we are finding the values of n. So when we solve this equation using the GDC, let me just bring everything on one side. So that can be n sin pi over n minus pi plus 0.005 greater than 0. So you have to use GDC to solve this equation, and you will find that n should be greater than 32.2, I guess. So it's n greater than equals to 33. So if you combine both the inequalities, because it says it follows both, let's just go back to the question and check. It says the inequality found in part H can be used to determine the lower and the upper bound approximation for the value of pi. Determine the least value of n such that the lower and the upper bound approximation are both within 0.005 of pi. Now this result shows that the lower bound will be within 0.005 of pi if n is greater than 33, and the other inequality shows that upper bound will be within 0.005 of pi if n is greater than 46. So if we combine both the inequalities, our answer should be n greater than equals to 46. So for n greater than equals to 46, both the bounds, the lower and the upper bound, will be within 0.005 of pi. So this had the least value of n. So for the least value of n, you should write n equals to 46. That's the solution of this question.